Hey guys, in this video I'm going to show you how to draw ray diagrams. This completely describes how your eye creates images using curved mirrors. Alright, you did kind of a form of this for plane mirrors, but this is a little different. Alright, so I'm going to do example 1 and 2 with you on this video. Problems 1 and 2 on Canvas. So I'm going to write number 1, if you could write that along with me on your array diagram template at the top. We're going to start by drawing an object where it tells us to. So number 1, it says DO equals 13 centimeters, right? So we're going to measure out 13 centimeters and place our object that distance from the mirror. Alright, so let's do that. 13 centimeters. I'm going to draw my object 2 lines high, and I'm going to draw it as an arrow. You do the same. It also says the focal length of this mirror is 6 centimeters. Alright, so I'm going to put a dot right there and label that F. That's where the focal point is, 6 centimeters from the mirror. So measure those two out. Put the focal point 6 centimeters from the mirror and the object 13 centimeters from the mirror. Now, where is the image created? To do this, we're going to draw 2 rays using our ruler. Okay, the first ray will be the red one. Let me get a better red marker than this sharper one. Okay, so our first ray will start out going horizontal from the top of our object. And that will be the first ray we always draw, going horizontally into the mirror. Do it with a colored pencil of your choice. And where does that ray reflect? It reflects straight through the focal point. That's our first rule, if you remember. All horizontal rays of light reflect through the focal point. Our second ray, so we use the red marker. Now our second ray will be done with the green marker. Choose the color of your that you like. And we're going to use our second rule for how rays reflect. We're going to send one through the focal point into the mirror. Again, coming from the top of the object here. Alright. Another green marker. Both rays come from the top of the object. Hit into the mirror, and this one that starts out going through the focal point reflects perfectly horizontally. You need to be precise with that, alright? Do not send that at an angle up or down, because rays through the focal point reflect horizontally. So where those 2 rays meet up is where the image is created. Your eye sees those 2 rays intersect right there, and it creates an image right there. But what part of this object does it create? Well, the light came from the top of the object, so where they intersect after they reflect off the mirror, that's where the top of the object is created. However, the top of the object now is below the principal axis, that's this line, of the mirror. So we can see that the object now is upside down because it's below the principal axis. So draw your object upside down when the light intersects below the principal axis there. So this was your object. Now this is your image created there. Plug in the power source. There we go. So now we're going to describe this object. Okay, is it virtual or a real image? Well, the image occurs in front of the mirror, so you could catch it on an index card like we did with the flame. That means it's real. Is it upright or inverted? Clearly inverted, because the light intersects below the principal axis. Is it magnified or reduced? Well, our first image was about 2 lines high. That's about 2 centimeters high, and now this one is a little less than 2 centimeters high. So I'm going to say reduced. Reduced in size. Magnified would be greater in size. And we're going to have to calculate the magnification for each image we do here. Remember, magnification is HI over HL. So we can measure HI. It's almost 2 centimeters. I'm getting 1.5 for mine. Everybody will get something a little different. You use your own number. But it's also upside down, so that's a negative 1.5. Any image that's upside down gets a negative height. And HO is the height of our object. So that is about 2 centimeters. 1.92 centimeters, something like that. So you could divide those up. 1.5 divided by 2. And you see that your magnification is a negative 0.75. Centimeters cancels out. And magnification, as you remember, does not have a unit. Box your answer for magnification. Because the magnification is below 1, that means it's reduced in size. So all reduced size images should have a magnification below 1, being a decimal. If the magnification was 1 point something or 2 point something, then it would be magnified, not reduced. It's also a negative magnification. All inverted images have a negative magnification. If the image was upright, then it would have a positive magnification. So negative means inverted. Decimal means reduced in size. Okay? Alright, let's do number 2. Okay, so number 2, we're going to look at F is 5 centimeters this time, so we'll write our focal point on our mirror. On the worksheet it says it's 5 centimeters. And it says DO this time, the object is at 2 centimeters. We're going to still draw it the same height every time. We're going to draw it 2 lines high. So that object is inside the focal point this time. So should we get a real image like we did last time? No, we're not going to get a real image like last time. Let's use our rules for ray diagrams to see where our image shows up. So our first ray is our red ray, just like it was before, and that one goes horizontally into the mirror. You use a color that you choose. And rays that go horizontally into the mirror, well, how do they reflect? They always reflect through the focal point. So we always draw our first ray being the horizontal one that reflects through the focal point. Our second ray goes through, you remember last time, our second ray went through the focal point and reflected horizontally. So we're going to do that. Except this time, the focal point is behind us. So we're going to draw the ray, instead of going through the focal point, coming from the focal point. So I kind of just line up my focal point with the top of our object and draw the ray sort of coming from the focal point instead of going through it. And how does that reflect? It reflects horizontally, rays through the focal point. In this case, because it's in front of the focal point, it's a ray coming from the focal point. It reflects horizontally. Now, where these rays intersect is where we have an image created. But these rays are diverging. They're never going to intersect or hit each other because they're going away from each other. However, if you look and you trace them back to the left side of the mirror, if you trace the reflected rays, that is, back to the left side of the mirror, they will intersect on the left side. So it has to be the reflected rays that intersect though. So take your reflected rays. This one was horizontal. And I'm going to trace them back with a dotted line just behind the mirror. These rays are dotted because they're not real rays of light. It's simply where I thinks the rays came from here, the dotted line. So I'm tracing the reflected rays back behind the mirror. And where they meet up, or I thinks they meet up, is back here. 3 lines high at that point right there. So this was your object, this was your image, right? So this is a little different when the object is in front of the focal point. Why don't you write that down for yourself, that this example is in front of focal point, that the rays aren't going to meet up on the right side of the mirror, on the real side. They're going to meet up on the virtual side back here. So you got to trace them back there. And the trick with the ray that's coming from the focal point, it doesn't go through it. It just comes from it. Okay, so let's describe this image. Well, it's not on the real side of the mirror. It's on the virtual side of the mirror. Is it upright or is it inverted? Well, it looks upright, like a shaving mirror this time. Is it magnified or reduced? It's clearly taller, so it's magnified. Right? Now we're going to calculate the magnification of the image. HI over HO. This is 2 centimeters high, my object. And my image is about 2.9 centimeters high. This image has a positive height because it's upright. The last image was a negative height because it was upside down. So this time my magnification is a positive number, 1.45. Positive means upright for magnification. And it's magnified, so the number for magnification is greater than 1. It's not a decimal. So greater than 1 means magnified. Alright? Thanks, guys. Now you can, there are do through number 9 on the ray diagram templates, and there's some more questions after that.